Hello. Okay. So we did this problem before in part 1 of the live stream, and now we are doing number 39, I believe. Let me just double check this. This is 466. We're doing number 39. Okay, so we have our altitude thing again, where we have one altitude and we have another altitude. And from the last video we learned that this triangle, and this big triangle, they're all similar, so the angles are the same, and the sides, the corresponding sides, they are proportional. So we're gonna be solving for x in this situation. Since this triangle has x in it, we're going to be using this triangle and comparing it with this bigger triangle. So let's first separate it out so you kind of get a feel of how this is going to work. That's the big triangle. This is a small triangle. It's a bit better. Right triangle again, the small one, x plus 2. This one is 5 plus x actually. Then this one is x plus 2. Let's put some corresponding measures here. So this one too. This double angle will be congruent to this one. Okay, so let's see the proportions with this. So the side which has the two angles, also known as the hypotenuse, the biggest side, is, we're going to take the proportions of that. So this big side is x plus 2, so let's write that down, x plus 2. Then the hypotenuse in this triangle is x plus 5. Is equal to, we can take the right angle and the one tick, which is x. Saying the one tick just to refer to what side. So right angle, one tick. So this is x plus 1. Okay. So that's x plus 2 is divided by x plus 5 because these are both hypotenuse, right? So let's go ahead and solve. X plus 2 multiplied by x plus 1, okay, is equal to x times x plus 5. Okay, so we have that there, and let's do let's multiply this out. X squared, we're gonna eventually end up with the quadratic. So just reminders, so we could do 1 plus 2 is 3x, 1x plus 2x is 3x, and then 1 plus 2 is equal to x squared plus 5x. Okay, here we have a quadratic, but we can see that they both have x squared, so we can just cancel that one out, and we're left with 3x plus 2 is equal to 5x we take out the 3x from each side. We'll end up with 2 is equal to 2x, and we'll end up with 1 equals 1. Now, let me double check that I have the right answer. Where did I get that there? Okay, so we cancel out the x squared and we have 5x. X is equal to 1. Yeah, so I'm gonna just double check with the answer key real quick. This would be 3, then this will be like 6. But, you know, I'm just gonna check. What did I do wrong here? Okay. So we have x plus 2, which is our hypotenuse, divided by x plus 5. That's also the hypotenuse of the bigger triangle. So then that is equal to x this one right here, it's like the one with, you know, the small side, x. Oh, hold on. How did I get x plus 1? Sorry guys. No, I can make mistakes sometimes too. So, actually, all of this is wrong. No, it's the wrong stuff. It's actually x plus 2. Because x is this one right here, right? And this is x plus 2. It's my bad because I put it very close to 1. Okay, so this would be equal to x plus 2 squared. And again, these two are the same, right? So we can use this is basically geometric mean, but we can't really take the square root of, you know, a quadratic. Or at least it will be kind of hard to do that if you can. So x plus 2 squared of x squared plus 4x plus 4 is equal to x squared plus 5x. Already removed these terms. 5x equals 4x plus 4, right? Then we do 4x minus 4x. X is equal to 4. Okay, so x is equal to 4 for this one. Let's clear up some stuff here. More clearing up to do. Or we could just remain it like that. So this is x equals 4. Okay? So this is only because like we can take out the x squared because they both have x squared, so we can just remove that. This is 466 and we're gonna move on to 475. Okay, so here we actually have a bit somewhat complicated system going on around here, and one of the questions I'll show you guys in a minute. Okay, so solve for x. Now we could use the, we could show that these are similar because the reflexive angle, and we have two corresponding sides, this one right here and this one right here, right? So we can prove that those two triangles, the one inside and the bigger triangle, they're both similar. So therefore the proportion should be the same. Let's start off with this side. Now there's actually, a trick here. I do not remember if I did this before, but you can just simply do 6 divided by x, because this is part of this side, and x, it's still, remember, it's a proportion, right? The proportion should be real. It's not about congruency anymore. Then we have 8 divided by 10. And I can even explain it with the whole triangle. Well, let's do this first. So we can actually simplify this. Get 6 divided by x is equal to 4 divided by 5. 4x equals 30. X equals 7.5. Okay, so we know that x is equal to 7.5. Now let's try to see this the other way, just to prove that, I'm not just making up something just to get a easy, easy way out, get my x value. So I'll erase this, and I think you can get what I'm talking about. So now let's take the bigger angle. So this 8 divided by this big angle is 18. Let's divide that by 18. Is equal to 6 divided by this big angle, x plus 6. Okay, we can simplify this. 4/9 equals 6. X plus 6. Basically, yeah, so basically we simplified it. Now we have to multiply. As you can see here, I'm doing way more steps, right? But we just have to get to our final product. Just doing the math here, distributing, solving, and minus 24 minus 24, 4x is equal to 30. So I don't even have to go on, because this is the step we did in the previous one, right? This is the step we did, and we end up with x equals 7.5. So basically I'm just saying that this the one right here is basically the same thing. So we can use that logic for the other problems. I was just proving it. Yeah, and you'll see that with many of the cases. It's because this is the same if we're only taking this part, right? So the side length is basically the thing we're taking out here. The 8 and the 6 we're taking out is proportional to the 10 and x we have. So basically these, are proportional. Okay, moving on. Number 11. So we have the same type of situation, and I think you guys can try to figure out the pattern here, that since these are parallel lines, they're technically all going to be similar, right? Because these are corresponding and so are these because of our transversals. So we have two parallel lines here. The triangle, or these lines, the angles within them would be congruent, which means these two triangles would be similar. So let's go work this out with the method we use here. We would do x plus 5 side divided by the bigger side, which is not technically bigger, you can literally see here, but that's part of the other triangle. X plus 5 divided by x is equal to 12 divided by 8. Okay, we can simplify this. X divided by x is equal to x plus 5 divided by x is equal to divided by 4 divided by 4. 2 multiplied by x plus 5. 3x is equal to 2x plus 10 minus 2x, right? We technically have x equals 10. Okay? So here we have x is equal to 10. Because we have, when we input it, we have 5 and 15. So I wonder if anyone else. Yeah, so we have no one here. So we have 5 over 15. And x is equal to 10. Okay. What is the value? Let's cover this up so we can see the question. Use the information shown on the auger shell. Okay. So, as we learned from the triangle thing, these angles that are all formed by these parallel lines are all going to be equal. I can even show it to you. So let's do these two angles. These two angles are congruent because of the corresponding side lengths. So these two angles are also congruent by the corresponding angles. These are also congruent, and we're going to use this parallel thing to show that they are. You could basically see here that the corresponding angles are congruent. So let's erase that. Now we know that, we can solve for y. So the sides would be proportional. So we would have 11 divided by 10 is equal to 8.8 divided by x. 11x is equal to 88. We can see clearly that x is equal to 8. Okay, so now for number 15. 15, solve for x. Same thing here. This 6 divided by x. I think, let me double check. 6 divided by x. Yeah. So that will be equal to 4 divided by 5, because these two angles are on the same side and these two angles are on the other side, but they have the side length. So 4 divided by 5, 4x is equal to 30, and we have x is equal to 7.5. I'm gonna show you something that's from the book. We have the bisector theorem, we'll go through later. So if there's transversals here, the segments are intercepted and the transversals are proportional. So AB divided by BC congruent to WX and XY. Okay, so that means well, the thing is, what I did was actually I did AB is divided by WX. I'll tell you why that works. Because there's this property where the diagonals, if we replace the diagonal, that is also true. So AB divided by WX equal to BC divided by XY. Okay? You can see that they are both, diagonal. So that's also true. And I actually should have done AB divided by BC. As we can see here, this forms out kind of a triangle. And we have like this triangle right here. And this bigger triangle. And this represents, the thing I was showing you. And this represents, hey, we took this off, but it's still okay. That's the Side-Splitter Theorem, I guess. XR or Q. Yeah, so basically the same thing. So let's go back to our problem. This is perfectly fine what we did here. We could have also done 4 divided by 6 divided by 5 divided by x. Now just, it gives you the same thing. It's pretty obvious. Even the reciprocals, which is 6/4 equal to x/5, are gonna give you the same thing. Okay, so that's one of the properties of proportions we can use here. Okay, fine, because we used it. Okay, so that's number 15, and we're gonna go to number 16. They probably should have left what x was here. X is equal to 7.5. Obviously, do not show this on the test. I'm just warning you. Okay, so we have 9 and 4 here, and we have 11 and x. So what we can do here is we can make this equal to 11 minus x, because that's basically what this distance is right here. Okay? And we could do 9 divided by 4 is equal to 11 minus x divided by x. Okay? So we can just multiply it. 9x is equal to 44 minus 4x. We can add the 4x, and we would get 8x 44. I'm double checking my work on the other side, but I don't want to get anything wrong here. Oh, oops. Yeah, so again, this is my mistake. This is 9x is equal to 44 minus 4x, so we add 4x. And we get not a good number, but this is what the actual answer is. So I didn't really expect the textbook to give us, this problem, but they did. So then we can just we get 13 times 3, 39, and then that'll be 3, and we would have 5. Wait, hold on. I think this is not right. Okay, so I think I got 5 out of 13 here. Okay, yeah, it's 5. Yeah, okay. Just double checking. Right. You always need to double check. So x is equal to 3 5/13 for this problem right here. Very weird. So let's erase this stuff. I'm gonna keep 5/13 there. Okay. So this is x is equal to 3 5/13. Okay, and also this is kind of like my thought process, so I may get, some things wrong, and I don't want it to be something that's like not, you're like, hey, no, that's wrong, you're saying wrong. But this is my thought process. Eventually I'll get to the right answer. I don't want to leave, the questions off with the wrong answer. So yeah. Solve for x. This is actually a new thing I figured out. Couldn't really see how it worked, but eventually I did figure it out. And basically it's this measure right here. And actually, for the first time, woohoo, I'm gonna switch colors. This one right here is proportional to this one. And hold on, this one right here is proportional to this. So basically what we have here is 12 divided by 10, or 10 divided by 12, is equal to x plus 5. Remember, we're going the right way. Oops, nope, wait, that's not it, because, oh no, because we're going 12, 10, and we're going x 5, so x divided by 5. So x to 60 equals 10x. X equals to 6. X is equal to 6. Okay. And that comes from triangle angle bisector theorem. CD is, CD divided by DB, then DB to the BA. I mean, CA. Yeah. So basically the same thing I did. Cause this is CD, this is CD, this is DB, this is CA, this is BA. Okay then, and that's for only if it's an angle bisector. Now for number 21. We have another angle bisector here. You can maybe start at this point. Go this. Root. It's 20 divided by x. And this one be 8 divided by 14. Oh no, I have to switch colors. 8 divided by 14. 20 x, and then we have 4, 7. 140 equals 4x. X equals 35. Check that, 140 20, 35, that's 35. You can check that if you want, but x is equal to 35 when you divide it. So yeah. Okay. 33. Okay, 33. So we have 4x divided by 5x. This time I'm not doing like this one and this one. I'm gonna do like the same side. so it makes more visible sense. We have a quadratic. Uh-oh, why do we have a quadratic? Oh no. But it's fine. We have 4x times 6x minus 10. So we have 24x squared minus 40x is equal to 20x squared plus 40x. Okay. I really want to be precise here. So 20x. Okay. So we have those two equal to each other. And we're gonna minus 20x squared minus 20x squared. Get rid of this. So we have then, I'll move this here. So I'll move this here. 4x squared minus 40x is equal to 40x. So what we could do is, instead of like adding 40x, we're gonna subtract 40x to get the other side equal to 0. So now we have 4x squared wait up 4x squared minus 80x equals 0. Now we can easily factor this out and divide it by 4x. And you might be wondering, wait a minute, what if x is a 0? Well, x can't be a 0 because this side, if we multiply this by 0, this is only going to be 0. And this is also only going to be 0. And this one would be a negative even. It will be super weird if it's 0. So we eliminated that possibility so we can successfully divide. So we have x minus 20 equal to 0. We have x equal to 20. A nice round answer. Okay. Now we can do 35. So we have a similar thingy-majiggy going on right here. So let's set up our problem. 12 divided by 7x equals 2x plus 2, 5x minus 1. So, we have another quadratic. 12 times 5x minus 1 equals 60x minus 12. So that's when we cross multiply, since it's a property. And then we'll do these two. We have 14x squared plus 14x again. Now we have 60x minus 12 equals to 14x squared plus 14x. So what can we do here? Okay, so I'll subtract 60x from both sides, and I'll end up with negative 12 is equal to 14x squared. 14 minus 60 would be minus 46, I think. I believe that's what I got. So 14 minus 60 would be 46x. Don't forget the x. And we would add the 12. And I'm gonna move all this here. And I'm gonna have 14 x squared, x squared minus 46x plus 12. Okay. So if you did watch, I think my first animation video, you would know how to factor this out, and you know, we would solve for 0. So let's start factoring. So we want to do 12 times 14, but actually before we do that, I'm gonna clear up some space here. Before we do that, we can actually make it 7x squared minus 46x. I mean 46x, because we're dividing it by 2. We're gonna get 23x plus 6. Okay, so, and we divided by 2 because 0 divided by 2 would be just 0, so it will be the same. And now we do 7 times 6 is 42, and two numbers multiply to 42 and add to 23, add to negative 23. So what two numbers multiply to 42 would add to negative 23? Well, we can see that negative 21, negative 2 would add to negative 23, but multiply to this. So we would write that out. 7x squared, 7x squared minus 20. Yeah, so if you watch my other video, you would know minus 21x minus 2x minus positive plus 6. Okay, so now we can factor these two terms right here. Okay, so we can factor this into 7x, because we can factor x from both sides. 7x times x minus 3 plus you could do negative minus 2x minus 3. Okay, so we have the same equation there. Yeah, you guys can hear Discord notifications. Oh, okay. Yeah, accelerated geometry is what we're doing right now. So we have 7x times x minus 3, and we have minus 2 times x minus 3. So we have 7x minus 2 multiplied by x minus 3. Oh, I can really fit this at the bottom of the page. X minus 3 is equal to 0. We're going to set this equal to 0 because it's equal to 0. X would be equal to 3. 7x minus 2. Ooh, that is very sloppy. Plus 2. 7x. 0 plus 2. Divide both sides, you have x is equal to 2/7 and x is equal to 3. So here are our answers for number 35, a bunch of quadratics. So thank you for watching this live stream. I may have done some mistakes here and there, but I eventually got the right answer, and I'm going to be ending chapter 7 homework right off here.